Hello everyone, welcome to the channel. Today I am presenting mechanical vibration MCQs. These MCQs are very important for different types of entrance exams. So watch this video till the end. In the first MCQs, it is asked that the natural frequency of a system with mass m and stiffness k is given by. So natural frequency, we know that it is the formula of omega n is equal to k by m. So the correct answer is k by m. In the second MCQs, in Coulomb damping, the amplitude of motion is reduced in each cycle by, that is, the correct answer is this one. In the third MCQs, the amplitude of an undamped system subjected to an initial displacement 0 and initial velocity x0 dot is given by. So we know that this is the correct relations, and in each the amplitude of undamped system, that is equal to this. In the fourth MCQs, it is asked that the effect of the mass of the spring can be accounted for by adding the following fraction of its mass to the vibrating system. So the correct option is option B. For a viscous damper with damping constant C, the damping force is, that is clear from this equation that this is equal to Cx dot, that is the derivative. C is the damping constant and x is the derivative. The relative sliding of components in a mechanical system causes, here it is the relative sliding. So the correct option is option A, dry friction damping. If it is fluid, then it is called viscous damping, and if it is in the form of a loop, that is some other type of damping, that then it is will be high hysteresis. Here it is dry friction damping. In torsional vibration, this displacement is measured in terms of a, so in a linear system it is linear coordinate, so here it is a torsional system, so the correct answer is option B, angular coordinate. The damping ratio in terms of damping constant C and critical damping constant is given by, here the damping ratio, we know that damping ratio is the denoted as zeta, and it is equal to C divided by Cc. C is the normal damping and Cc is the critical damping, and it is also called isolation factor. So they also ask as in the isolation ratio in terms of damping constant C and critical damping constant is given by. So the correct answer is option B. So next MCQ is the amplitude of an undamped system subjected to an initial displacement x0 and an initial velocity 0 is given by. So here is the correct option is option A. It will be equal to x0. The phase angle of an undamped system subject to an initial displacement x0 and initial velocity 0 is given by. So here it is asked the angle between the displacement x0 and initial velocity 0. So if the initial velocity is 0, then the option is C, 0. The energy dissipated due to viscous damping is proportional to the following power of the amplitude of motion. So the power is 2, option B is correct. For critically damping system, the motion will be it is mostly students write it wrong, periodic, but it is aperiodic, so option B is correct. The energy dissipated per cycle in viscous damping with damping constant C during the simple harmonic motion equation is given by, so this is full relation in which the final answer is option C. For a vibrating system with a total energy W and a dissipated energy change in W per cycle, the specific damping capacity is given by, so it is all the specific damping capacity. So damping capacity is given by change in energy divided by total energy. So the correct option is option B. If the characteristic roots have positive real values, the system response will be, if the system has positive real values, then it will be unstable. Or MCQs have been also asked, if it has negative real values, then the system will be stable. So here it is asked positive real values and it is unstable. Next MCQs, the frequency of an oscillation of the response of the system will be higher if the imaginary part of the roots is. Let's discuss this MCQ because this is very important. There it is the imaginary part, and this oscillation also shows the frequency. So the higher this oscillations, the higher the imaginary part and the higher will be the frequency. So the correct option is option C. In the 17 MCQs, if the characteristic roots have a zero imaginary part, the response of the system will be, so it is clear that if the imaginary part is 0, so the oscillation will be 0. So the correct option is option B. The shape of the root locus of a single degree of freedom system for zeta is between 0 and 1 is, so the option is circular. If the zeta is between 0 and 1, the option is 0 for a single degree of freedom. Last MCQs of today's video is the shape of the root locus of a single degree of freedom system SK is the correct option is option A, vertical and horizontal lines. So that's up to today. If you don't understand any single MCQs in this video, please ask in the comment section, and don't forget to share with your friends and like and subscribe the channel.